Hi, in exercise C-5 we face a very practical problem. So we have a large conveyor, a very long one, 250 meters, and we have two drums driving this conveyor. So please remember, we should divide the overall torque by 2, and there's electric motor on each side of the conveyor. So we have two motors driving the respective drums. And we also have two powerhouses quite close to each side of the conveyor. The one on the left hand side has a voltage source of 690 volts, and the one on the right hand side has 6 kV voltage source. Also, you should note where cooling water is available, so that you can use this cooling water for making your equipment more compact if you need to, and change the price of your components. So please try to design the overall drive system for lowest possible cost. So you can choose whether you need transformers or you do not need them, and what will be the voltage level in your drivetrain, and where you take the supply. So you can use just one powerhouse where you place all your equipment, or can use both powerhouses. So it is a very interesting and very complex exercise. Let's dive into the sizing software. So first we set up all the parameters, and we know that the rated torque is just a half of the overall rated torque, because we drive only one drum with one motor. So this is correct. And we see the motors and the converters are there, everything is chosen. Just note that the cable length is just 30 meters, and it's 99% efficiency in the cable. But what if we need the longer cable if we want to drive the motor from the distant powerhouse? So what happens to the cable now? So we see the efficiency is quite reduced. It is 94% instead of 99%, and the cable gets quite expensive. It is 29,000 because copper is expensive and the installation is expensive. What we can do, we can try to play with the cross section of the cable to increase its efficiency by reducing losses in it. So increase slightly the copper cross section, and it's now 95%, but the cable gets even more expensive now. So since we have the long cable, we most probably need a filter, output filter for our frequency converter. So we choose DUDT filter, and now we see the frequency converter price went up because the filter is also expensive. So we see the how the price is affected by the choice of the cable length and the cross section and the filters. So now we can go up and see what we get in the report. It is 400,000 in price for the total system, and this is the efficiency at rated load. 88% is not too high. Well, now if we bring the cable cross section to 400 square millimeters, we can see that we have some improvements in the cable efficiency. It's 96% now. The price is also 47,000. It is high. Now let's try the system with the transformer. So we now have a short cable because we take the closest powerhouse with 6 kV, and we see that efficiency of the cable is quite high, so just very low losses. What can we check here? We go into frequency converter and we look through the parameters. We can play with cooling, of course, here, but we do not need, by the way, any filter between the frequency converter and the electric motor. So we reduce the price by that. We look here, it is just 377, even though we have a transformer as part of the system, but we saved quite a lot on the cable and the filter. Now if we want to try systems with gearboxes, we should consider both variants, with transformer and without transformer, and this may help us to make our system even less expensive. So it's worth exploring. Thank you for watching.